We'll begin by demonstrating some of the customization features on the screen. So right now we're toggling between the different available units in which you can show the speed. Right now also we've switched from the automatic lighting mode to the manual one, which starts at whatever level's been determined by the automatic algorithm and then lets you adjust the brightness from there with these up and down arrows. Right now we've jostled the bike a bit so you can see what the brake indicator would look like, and also notice that as you press the left and right turn signals, you get these nice yellow indicators on screen so you can see what's happening in the rear of the bike without having to turn your head. We wanted to show you how all these features come together in the real world. So right now it's nighttime outside my house, and you can see I've put on the right turn signal as I'm about to make this right turn. The left turn signal also works. You can see that I already had it going into this turn. I've turned it off while I'm on this straightaway, and I'll turn it on as I begin to make this next left turn here. Also, we wanted to show you the effect that the headlight has on revealing the path in front of you. So you can see in this especially dark area between the trees, the headlight is doing a good job of showing the road in front and especially revealing little cracks and twigs in the road that you otherwise wouldn't see. Right here, as I begin to slow down, you can see that the brake light has been activated, and as I get off, it turns off again. This is another example of the brake light working. So there's these two people coming down the far path, and I noticed them, so I put on the brakes and the brake light activates. However, once I make the turn and I see that there's no one else on the path, I pick up speed again and it's off.
From here, we'll briefly move on to demonstrating how the same electronic capabilities previously shown on a bike can be implemented with a children's scooter. Due to the scooter's smaller size, the primary differences are mainly having more compact mounting pieces. This is especially noticeable with the blinkers, where the button and light are both integrated into a single module. Finally, we'd like to transition to explaining exactly why we chose to create our modified bike and scooter. We were ultimately inspired to make our ES50 project by seeing how many essential safety features ranging from blinkers to headlights and a taillight are present on electric and gas vehicles. From there, we noticed that those features are entirely absent from most manually driven vehicles. So, we were determined to add as many of the electrical safety features into a scooter and bike as we could manage. We're glad to exhibit how manually powered vehicles can be made safer for both the driver and nearby pedestrians without reaching the cost of typical electric and gas vehicles. After all, many people still buy manual bikes and scooters due to their relatively low cost, a desire to get exercise, or simply for enjoyment. There's no need to forgo safety in these cases. We hope that our project provides greater understanding and excitement surrounding the prospect of safe and intelligent manually driven vehicles.